you have mentioned research on alternatives to reinforcement learning from human feedback, RLHF. So, RLHF is today a very common practice for often the final step of training a large language model to have outputs aligned with the kinds of outputs that humans would like to see. So, this could include listeners are probably familiar with in ChatGPT. You can give a thumbs up or thumbs down to a particular output, and that thumbs up, thumbs down can be used in this reinforcement learning from human feedback to fine tune the model to have the kinds of outputs that humans are expecting given a particular input. It can also be useful for safety purposes, for safety alignment. Um, and there are alternatives. So I think the only one that I have any kind of immediate familiarity with is reinforcement learning from AI feedback, RLAIF, which Anthropic favors. Um, and so, yeah, so you've previously mentioned alternatives to RLHF. I'd love for you to take the floor and fill us in on more.
Yeah, so also a nice spontaneous segue here. So these alternatives. So first of all, like RLHF is like I would say it's labeled as reinforcement learning, but I would say it's almost a bit different from a reinforcement learning, let's say, applied to robots. But so the idea is essentially that you train, you have your, so that multiple steps. So you first have your pre-trained LLM, and then you follow up with an instruction fine-tuning step where you have a data set where you have instructions like summarize this text or translate this text, and then a desired response. And so you teach the model to better follow these instructions. And this is just regular supervised fine tuning. So in pre training, you have this next token prediction task where the language model always learns to predict the next token. And the correct response, so if you during pre training have an input data set, the target data set is essentially the input data set shifted by one position. So you always try to predict the next token. And instruction fine tuning is essentially the same thing, except it's one step. So if your input is the instruction plus the desired response, the target is that same thing shifted by one position. So the model, I would say, it doesn't soak up as much knowledge as during pre-training because there are fewer training steps involved because you give it the full input basically. It's one step, but it learns like the structure or the instructions. It works surprisingly well. I think the first project was Alpaca. There might have been other ones, but Alpaca was a popular one where people tried this, and surprisingly, the LLMs were capable of following instructions pretty well. But this was usually, I think, this was done because it was convenient to do it compared to implementing RLHF, which is more work. But RLHF is what researchers at OpenAI did for ChatGPT, but also Llama 2 at least, the chat version. So the process is then that you take this supervised fine-tuned model. So you still have to do this step, but then you train a reward model. So you collect, like you said, these thumbs down and thumbs up and thumbs down answers, where you get human preferences. So you have the model generate always two responses. You take that supervised model, and this generates two responses, or you take one. You don't have to have it, let's say, generated, but let's say you have two responses in a data set, and one is better than the other. There's the preferred and the chosen and the rejected response, essentially. And then you train a model essentially to predict, like a reward model to predict which one is the preferred one with a score, essentially. And then you use that reward model to train the LLM to give preferred answers. And I'm just thinking about RLAF, which is the reinforcement learning with AI feedback you mentioned. I've written about this like last year, but it's already such a long time ago when I remember correctly, but please correct me if I'm wrong. It's the same process, except that instead of humans providing the feedback, it's something like GPT that provides the feedback. Is that correct?
That's right. That's my understanding of it as well,
Mhm.
where it's not a the approach in terms of the mathematics
Mhm.
is not different. It's
Mhm.
just that you're getting the preferences from um, an AI system as opposed to from a human.
Mhm. Yeah, and I think that's done because it's very expensive to get these human responses. And yeah, thinking about it, maybe labeling responses like thumbs down and some thumbs up is not the most expensive task for a human. It's maybe something you can do quickly, but if you think about writing the instruction in the first place, that's quite time consuming. And I think you have to fact check me on that, but I think Llama 2 they used 1 million responses or something, which is a crazy large number to do the RLHF. And yeah, and I think if you use then something like GPT-4, I mean, yeah, it's all automated. Then you don't need to have someone do the laborious task of writing these responses and rating them. And I think also then that would be so. One thing also related to that is a lot of people. So one challenge is how to evaluate large language models, and one is of course they are automated metrics. For example, you have a question and then you check whether the model gives the correct response. And usually that works well if you have a multiple choice quiz. Like you have four answer possibilities, and the LLM gives you the correct answer. Or math, where you have what is 2 plus 2, and the model ideally answers 4. And but this only can cover so much. It can cover like correctness. And if you want to evaluate a LLM based on the conversational abilities, I think it's also tricky. The gold standard is really still asking humans, like which answer do you prefer? And because that's quite expensive, especially if you think about academic research, also a lot of people use GPT-4 for that, like having a human preference. So it's like essentially asking GPT-4 which answer do you prefer, and then you compute the percentage of or you if you have two LLMs, you basically ask it which LLM gives the better answer, and then you compute a win percentage. Like in let's say 80% of the time, this LLM produced better responses than the other LLM, given ChatGPT 4 or GPT-4 as the judge. And I think this is also then I think pretty closely aligned to how humans respond. Like if some people do sometimes the comparison between human and GPT-4 judges, they're very close, and that tells me that okay, maybe GPT-4 is actually quite good at providing the correct or the preferred response that most humans would prefer. And then something like reinforcement learning with AI feedback that I think would work well then also because it is pretty closely aligned with humans. It's maybe a chicken egg problem because GPT-4 was trained to prefer human responses. But so this would be one alternative to RLHF. But what I wanted to get to was actually more like mathematically different approaches. So RLHF requires this reward model that you have to train, which then is used to further align the LLM. And some researchers were wondering, is this actually necessary? Why do we have to have this extra reward model step? So I forgot the authors of the paper, but there was a paper called DPO, which stands for, I think it was direct preference optimization, where it's an approach essentially where you skip the reward model step. You directly provide the correct and incorrect response and directly train on that with cross entropy loss. And that is one alternative, and there's another one, KTO, and I forgot the what it stands for. I think it was Kahneman something. And this is interesting. It's kind of similar to this DPO method in that you don't have to have a reward model, but both DPO and RLHF, what they have in common is that you have thumbs up and thumbs down answers. So you have to have a comparison. So for each data point, you have to have always these two answers. And sometimes it's maybe not the most convenient thing to collect. So if you think about maybe even a search engine, when you have a Google search engine and you type responses, you only click on one answer, or if there's a movie, you only select one answer. You don't have always a pair and then say, oh, this is better than the other or something like that. You maybe have an absolute score. And I think KTO works like that, where it only requires, let's say, a single score instead of having a pair of answers, which can be beneficial in certain applications where you can't collect a direct comparison. So, yeah, I would say these are the three methods that come to mind that are right now the most promising ones. And they have different trade-offs, I guess, but all are good or interesting methods to look into, I think.
Nice, yeah, and I guess so as the kind of baseline there, RLHF, I guess we would typically call that PPO,
Mhm. Yeah, that's the
that exists today.
Yeah, that's a good point. So the PPO algorithm is essentially the algorithm that then takes the rewards and applies the updates to the model.
Yeah, and I did also I hadn't heard of KTO before, but I did a quick real time fact check here, and you're right. The K is Kahneman, and it's
Ah,
interesting. The T is Tversky. So
mhm.
Kahneman and Tversky are famous social scientists and economists who collaborated on tons of super high impact papers over several decades. Kahneman is still alive and is famous, for example, for the book Thinking Fast and Slow, and he's a Nobel Prize winning economist and so on. And so, yeah, it is interesting. I haven't had time in real time here to look up the link as to why they're calling it Kahneman Tversky optimization, but it must be inspired somehow by research that they've done, um, something like that.